We've done graphing with sine and cosine up to this point. Now we're going to talk about the inverse of the graphing. So today, 4.6, so we're starting new unit. 4.6, we're going to be graphing secant and cosecant, or in this case, cosecant first and secant second. Cosecant being the inverse of sine and secant being the inverse of cosine. Let's talk about the generic cosecant graph. So our generic cosecant of x graph here is, let's think about all the inverses that we could have, right? So at 0, so let's go from 0 to pi over 2 to pi to 3 pi over 2, so then negative pi over 2, negative pi, and negative 3 pi over 2. And this would be, this would be 1, 2, 3, say negative 1, negative 2, negative 3. The inverse of when sine, right, a sine at 0, sine is 0, right? We can't have an inverse of 0. We just can't. So whenever sine is going to be 0, our cosecant doesn't exist. So it becomes our asymptote. So at pi, it's also an asymptote because it just can't exist at pi or 180 degrees. So here this will also be an asymptote, just like so. The next asymptote is going to be at our x-axis here. And now we just have to graph accordingly. It kind of goes like a U. And the first part, it wants to go U here. And then the second part, it flips upside down. So, and it goes U here. And then it goes U here. And U here. And that is our cosecant. So if I put in the, that's our cosecant graph. Our secant graph, so let's do our secant graph over here. Secant of x. Same thoughts. We have 1, 2, 3, 0, pi over 2, pi, 3 pi over 2, negative 1, negative 2, negative 3, negative pi over 2, negative pi, and negative 3 pi over 2. The same thought for our secant of x. Wherever our y-coordinate, right, secant is the inverse of cosine, so wherever our x-coordinate is 0, we have an asymptote. So our x is 0 when it's at pi over 2. So our asymptote is at pi over 2. And 3 pi over 2, that's our asymptote there. And negative pi over 2, that's our asymptote there. And negative 3 pi over 2. And then the basic one is our central is at 0. And then it always goes up in the first parts, kind of like parabola-ish, but not quite exactly. Kind of like this. It goes up first, and then it alternates up and then down, and then this side should also be down, and it will go in a pattern just like that. Now let's add all the things that we know into one example. Let's say I have, I'm going to use this as my guide. Let's say I have y equals the cosecant of, let's say this is 2 times x plus pi, and there, minus 1. Let me try to clean this up, make it look somewhat presentable. So there is a lot going on here. We got a vertical shift of 1. I'm not going to ask you to write all this down. You should be able to know that by now. And this 2 here is kind of like an amplitude, but instead of making it like longer, right? It condenses each portion. It condenses each portion, so then instead of having our full portion, it makes it half of it. Okay? And then the next one is this x plus pi. That means it has a phase shift. Everything is moved 180 degrees down that way. So let's graph this using all that we know. We're going to use this first one as our guide. Okay? I'm going to use the first one as our guide, and I know that what is important to know is that our asymptotes. So our asymptotes originally were at 0 and pi. And now we want to move them back and make it thinner, right? So first we have to half it. So move it back to pi. Well, that's convenient for us because now our current asymptotes will still be 0 and pi. Those actually would make sense. 0 and pi would still be asymptotes. But now we need to half that. Half of 0. Half of 0, no, this is still 0. Half of pi would be pi over 2. So now we have an asymptote at pi over 2 and at pi. So 0, pi over 2, and pi. Because now, because of this 2, we double it. So we go here. This is 0. This is pi over 2. This is pi. This is 3 pi over 2. And we'll go, this is 1, 2, 3, -1, -2, -3. We have a vertical shift down of 1. So now my horizontal asymptote is there. I get another asymptote here, another asymptote here, like so. Another asymptote, no, I didn't put in those units, but they're there. They are there. And now I can kind of draw this just a little bit. My secant graph. So the first one is always going to go up, right? So the first one after my 0, so from 0 to pi over 2, it's going to be my up, the first one up. So this one's up. It's going to be like this. And then the second one's down. It's going to be like that. The third one's down. Going to be kind of like that. and they alternate accordingly. It doesn't have to be perfect. But that is how we can graph. The important parts to reminder is the asymptotes and where they should be at.